Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 81. In today's lesson, we are going to be looking at testing a little more. In particular, we are going to look at mocking. So the idea of mocking is you're making a fake object you're using for your tests. And we're going to have to adjust the code a little bit for how I intend to implement it. So we haven't done this before, I don't believe, so we will begin by adding a mocking library. So if we look at our unit test project right now, come here and press F4. It did not work. Come here and right click and let's see. Is there not a way to actually see that? I was wanting to see the CS project. There we go. Edit project file. There we go. Alright, so right now there's we have XUnit, Coverlet Collector, Microsoft .NET Test SDK, and the Visual Studio Runner. So those are the things that get added when you create a test project. We're going to add something to it. I don't believe we've done that before, so I'm going to come here, right click, and go to Manage NuGet Packages. So in .NET, NuGet packages are NuGet's the .NET Package Manager, so it lets you install packages. You can see here some of theirs are XUnit. These are the ones, that one's deprecated, great. These are the ones though that we have seen there in the thing, and some of these are pretty out of date. I might consider updating these as well. The one we're going to add is it's called mock, M-O-Q. Browse. Switch over to browse, and it's this one here. So this is one of the this is one of the mocking libraries. There's several. You could use mock. There's in substitute. Make it easy. I'm going to use this one though because I think it's probably the most common. 1.18 billion. Can't spell. There. Yeah. So it's the one I've seen the most of, although I have seen the others, but I've seen it the most. So I'm just going to grab the latest stable. We're going to install it, and let's see. So I thought it told you where you were installing. So for full disclosure, I have not used Visual Studio for this. Yes, I just click install and it takes me to the right spot, hopefully. Yep, unit tests. Okay. So where I select it, right. Yeah, NuGet unit test. Okay. There we go. So now we have installed it. I'm going to come over here and update. So what we can do is we can check these other ones here and see if we can update some of them as well. In fact, I'd like to update all three if I can. We'll try it and see. It may not work. Alright, so it's uninstalling Newtonsoft JSON, and it's installing all of these. So we seen when we looked at it, there was only, so they are MIT licensed. And when we looked at it before, we only seen 4 dependencies. There's some transitive ones though. There's 11 here that are transitive, so that means they come through that. You see there's a lot of XUnit, Microsoft and system functionality, and Castle core. Yeah. So XUnit 3 is separate. So if we look at browse, there's XUnit, and then there's XUnit 3. Put a 3 after it. Yeah, XUnit v3. There we go. So that's the upgrade to XUnit. I don't think I'm going to pick it up here, as I think we're going to leave it, even though it's deprecated here. May plan to do that plan to look at that maybe next time. But since we're already on X Unit 2, I think I'm just going to stick with that for now. But there's this test. So now this file has changed. And now we have added mock. And we have updated this as well. So hopefully everything still works. So the good thing there is, let's go ahead and rerun our test real quick to make sure. And if so, we will begin trying to use mock here. Alright, test succeeded. Alright, so the easiest thing you can mock is a interface. So basically you give it an interface and you say, okay, mock this. Our functionality here is pretty easy to mock with. So I see us having, we have a heap, we have a tree, and we have a dictionary. So the three of those are data structures. So they're almost the same, except tree has a little bit extra functionality. So they have some way to insert, some way to remove, and some way to find in the tree. The tree, or in the structure, the tree on the other hand also has the in order traverse in order. So what we can do here is we can do a little, if we come over here, let's go to red black tree. So let's add an interface. Let's see if Visual Studio has a extract interface. Let's see if what it can do. So there's what it thinks it needs. Binary tree. Let's do it like that. We'll put it in a new file and it has these methods. So let's see what it generates. Let's just see how it works. F12. Okay. Public interface, and it has these methods. So that seems reasonable. So for the other one, so for a heap and dictionary, I don't see these as needing any other behavior. I guess heap has a peak, actually, never mind. I was going to say, I don't see these having others, but yeah. With having a remove, we have a peak and an insert. Yeah, let's do it for it as well. So if we go, let's see. I did right click, right? Was that what I did? Control dot. There we go. Extract interface. Let's do this one. Binary heap. Yeah, count as well. Okay. So we have a binary heap. Then we have the dictionary. So the dictionary is interesting because I think there's already a interface for dictionary. But we can't instantiate it the same way. So now it would have to be new dictionary of int player. I think if I add parentheses, I think that will work for us. And now, with those interfaces in place, now this can be a binary heap and new max heap. Binary tree. This one can be a new red black tree. And there we go. So we're only using those one spot for the moment. However, there's this one's interface. I didn't look at it, but there it is. We're only using those in one spot, so the interface doesn't feel that useful yet. So let's come over here and try testing it. So when we talk about mocking, there's different terminology that'll come up. You can sometimes hear mocks and stubs and fakes and a spy. Each one of them has a little bit of different, but they're all forms of mocks basically. The most explicit one is a mock. So the idea of it is you're verifying your interactions basically. So for try add player here, we could mock these two values here. And when we do so, we can make sure that we get what we expect as values here, so we can mock it and then make sure we actually insert a player, we insert players into both of these and do all those operations. So we're gonna experiment with that first of all. Let's come over to our where did I just put this? So we called this remove player. I'm gonna rename that. So I'm gonna press F2 and that doesn't do it. Control RR. We're just gonna call it remove. Player here's player, so we're removing. So that's what we're removing. That's the binary heap. Let's go to the tree and do the same thing. Instead of delete, we will swap this to RR remove. And because those are linked up, that should have changed it everywhere. So let's check and see. Yeah, there's some green down here, so it looks promising. Remove. We come over here, leaderboard manager. Yeah, we got some removes here as well. So yeah, I feel like that's what we want to do. So I think I don't want to do that. Let's test these first. So back up here in the try add players. So we did some testing up here. So we add a player when duplicated. So we're making sure that the general functionality does so. We're testing the contract, we're testing triad players, and what happens. So we can also, I'm thinking if I want to change this one or not. I sort of like the test as is, but I'm thinking if we want to actually change it. I'm gonna run them again real quick, make sure we didn't break anything before I start. Yeah. All right, so yeah, let's do so when not duplicated. So when it's the non-duplicated player we add. So we're gonna have to do a little more work here. So right now there's no way to get to these, so we couldn't actually do anything with these heaps or anything. So the way to get around that is you inject them in. So this is called dependency injection. So let's do a public leaderboard manager. That's probably what we want right there. Yeah. And then we don't have to do all this. So now we're setting these in the constructor so we can remove the instantiation. This has a problem though. Now we have to go actually create these somewhere. So over here when we create the leaderboard manager, we actually need to make them. So now there's more stuff we have to create over here. So let's see. So we will have a dictionary of int and player. Players equals new. And here we can use the other functionality. Players I presume heap was next. I actually didn't check. So we'll create a max heap. Max heap equals new. And then red black tree. Tree equals new. So this is called dependency injection. So we moved where we created them. So now we're passing them in here. And we're like, that adds more functionality here to main. So what I might consider is maybe moving the display out and have main be more along the lines of, all right, this is the basic setup, and then we call something the maybe run or something maybe. But we'll think about that. So let's add a to-do for that. To do, consider pulling remaining functionality into separate method class. So we'll add that to do, and I'll think about that later. That's not what I want to focus on today. But now we're providing our players here. So now over in Leaderboard Manager, let's do this. Let's just do it like this. I'm doing this so we can see what's happening. This is not required. But now we're saying, okay, we require passing these in. There's other ways we could do this too. What we could do here, we could pass these in as nullable and make them null by default. And if it's null, we set them in here. That could actually work as well. And then we don't have to create them over in the program CS. I'm trying to think if I like that or not. Basically, then in that case, they don't get created until they're needed. But the fact for this program is they're always going to be needed. I think I like them better being passed in, so I'm going to leave it like this for now. We might consider that later, but I think I'm going to leave them like that. And here, this looks very much like a primary constructor. I bet that's what that's saying. So if we take that, if we fix that, or not, there. It's saying we can just make them in the primary constructor, and that should be fine. So now our tests are failing though, because we need to pass in some information. So we need to pass in these same handling here. So there's multiple ways you could do that. You could do no, I don't think I want that. I think I want it to stay how I have it. So I'm going to keep separate these. They're probably not required at this point. I could just use them here. So in fact, let's do this. Let's do to do consider just using the primary constructor values. So that would work. I'm not going to make that change yet, but we might consider doing that as well. But over here now, so we're going to need to pass in those values since we didn't go the null route, so we need to actually set them. So there's a couple ways we can do that. So here we only need to worry about what we need. And in this case, we need all three, so we don't get anything from this one. So over here, we need to make something that's act like the structure here. So what we could do is we can create a mock. So I'm going to do a mock, and I'm going to give it a type of iDictionary of int player. We're going to call it mock dictionary equals new. Does that not work? No. Using mock. So now we have a mock up here. So there's this one. So we need the other two as well. Mock I binary heap. Mock max heap equals new. Mock I binary tree. Mock tree. So now we have those three. So now we just pass those in. Mock dictionary. So there's going to be a problem here. We'll fix it in just a second. Mock max heap. Mock tree. Here, we don't need to say max heap here. Mock heap. We don't actually care. So there's a problem though. Dictionary is not null. So it says this doesn't work. Cannot convert from that to system collection. So it's saying it's not a dictionary. And each one of these is going to say the same thing. It's not an binary heap, and it's not that. That's because it's a mock of that. So what you do there is you do dot object. Dot object and dot object. And now it compiles. And in fact, if we run it now, oh, there's bill errors. Wait a minute. Oh, all the other tests. Here, let's do this. Let's copy these. It's going to be the exact same thing each time. Let's do this another way. Let's do this. Let's do private leaderboard manager initialize manager. What I'm thinking here, it doesn't give us the control we want actually. Yeah, I don't really get a lot out of what I'm about to do. Let's do it anyway, but just to see something we can do. But there's other ways you can do this just as easily. What I'm thinking was to create a method here that just takes these and fixes them for you, so you don't have to keep doing it. I don't think there's actually a lot of value in it, though, actually. Return new leaderboard manager and passing in all of those so mocked. Mock dictionary dot object mocked heap dot object and mocked tree dot object. So now let's get rid of these. Now we have this method here. Let's make it so we can actually read it. So we got a method there that does basically this. So we're not saving a lot here. Return initialize control RR. And it can be static. I actually don't like that in this case. There. So yeah, that doesn't save us a lot of typing. It saves us a little bit. So we're grabbing the object out of them like that. But so we don't see the value of this yet. So let's do this. We'll copy this. I'm going to put it here, 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 So we are extending the code right at the moment. We will try to clean it up afterwards. So right now we're just doing a little bit of cleanup here. We're making this anywhere we do a new here. We're letting it handle all the setup for us. This should get all the tests at least building again. But we still haven't used any of the new functionality. Okay, so now we've added a lot of code, but we haven't done anything valuable yet. So let's do something valuable. So here we fail some tests. So what did we fail? So we fail almost everything. So if we look here at what we got, different value. Expected 1 got 0. And let's see, did our test fail? Yeah. Let's set a breakpoint here and let's see where that fails. Well, we think it's right here. Right here, I guess. So what happened? All right, so we are here. So result equaled true. So we added a player. So that means our count should have went up, right? But it didn't. So count we're getting from player count. So test player. Test player looks fine. System under test. What does it look like? Our player here. It's got a count of 0 and it's got. Let's do it down here. It's got a count of 0. It's got some other stuff here. It's got a mocks, got an interceptor, got some values, but nothing's happened here. So when you have a mock like this, you have to set it up. So you don't have to set up everything, only what you use, but in this case we're using some functionality, so we need to do some setup. So we're doing try add. So what we can do here, we can do, let's just do another section here. We will do mock dictionary dot setup. I'm just going to use D for dictionary dot try add, and we're passing in a player test player ID, and we're passing in test player, and we'll say dot returns, let's say returns false, let's say returns null, and we'll have to force it to return null. So now let's see what happens for a second, and we need to stop our test run here. Right. Let's try it again. So now what happens? System not supported exception. Unsupported exception. Can't take to null. Okay. So let's make it so it's true or false then. So we try the add. Let's say the add fails. So now we're in control of that. So anytime that inside of wherever we use mock dictionary here, so anytime if we try to use try add and it matches this invocation, so an ID of 1 in the test player, then it's going to return false, and we can check that here. So we're going to add a breakpoint here a second, and let's debug this test again and let's see what happens. All right, so we may actually have to do a different thing with our dictionary. It may not. Dictionary may not work like I thought it did. So what it's saying is triad here can't be used because it's in an extension method. So let's check that. Collection extension, so it is a dictionary extension. Interesting. I actually don't know if I knew that one. Let's do it like this. Let's do our own then. So we will have to make another adjustment. So let's do this. We will do a public interface. Let's call it I player dictionary. It's going to have similar things to our other data structures. We will have a int count get. We will have a insert. What values do we insert? We return a true. We'll insert player. For remove, what do? We remove. We return a result. So bool remove player, and then find, we just find the player, right? Yeah. So we'll have player, find player. It needs to be null. That might should be player ID in this case. Yeah. Should be ID and name. So we'll have player name. Oh, wait a minute. These just call the same thing, don't they? Let's do it like that. So we'll have an int player ID. That should get us there. That should be the functionality we need. So let's implement that. So we'll implement it as a public class player dictionary. So it's going to have a backing field here of a read-only, a private read-only dictionary, string player, players. All right. So it'll have a count property. So the count, let's make it just implement this. All right, count returns players.count. Find player. It's just going to return what we did down here, right? Just return these. It should be int. Okay. So insert's going to look very much like this. We're just going to try add. Return that. And remove, we are just going to do this one. So there we go. We've implemented our class, right? Needs to return. So there's just a player dictionary. So now we need to use that. So now we will have a player dictionary. Now it's not generic, so we don't need this anymore. It's the interface though, and over here in program we need to do that. Player dictionary, new, and there we go. Player dictionary. There we go. So now there's a problem though in our test. So we made another change now. So now we need to go actually adapt over here. We need to adapt the functionality as well. So now instead of this, we will do we'll just do players.insert player. Here it's just going to be remove player. Here it's going to be return player.find player, passing in the ID. Same thing here. There. All right, that should restore the functionality. Now we need to come over here and we need to make that adjustment as well. Here I'm going to do Control Shift. And I'm going to press semicolon. So that selected everything that's iDictionary here. So we're just going to say iPlayer dictionary. Now we change that in the entire list here. So now we don't have a triad, we have a insert. Now it's a test player. So now if we come over here and set our breakpoint, we should get a little bit different functionality. And here, let's do this. Let's move this to its own class, or on file, not class. Same here. I don't know why I can never find that option there. But yeah, now let's see what happens with the test. So now if we run it or debug it, let's see if we hit over here. All right, so it didn't stop this time. So now we set it to return false, so it inserted. So now we have a count of 0, so everything's still good. And it returned false. So we went false. So okay, so that's not right, but it did work. So let's continue. The assertion fails. Assertion fails. So now let's make it return true and let's see what happens. So now it's going to return true, and let's debug it here and let's see what happens. All right, so F10. Return result is true. So we get past that point. So just by doing this returns here, we have now controlled our insert method. So we're saying, okay, we inserted and insert says it succeeded. Notice that there's no value in players. So players is still count 0. We did not change the count. So we're in complete control at this point though. So what we can do now, if we do F10, notice those didn't fail because they're not returning anything, so there's nothing it needs to worry about. And we return true. So as far as the test looks, we actually finished. So now we're back over on the other side. So now count is 0 because we didn't update count, so it will still fail. So we need to set up the count as well. So count here, we do something here. Let's do this. We'll do returns. So we added one value. So now what happens? So now let's here, we're just going to hit run here because we're going to be able to see what something odd happened. So it fails. Assert value equals. We expected 0, but we got 1. We're expecting 1, but we aren't here. So when you do a setup, it sets it up every time. So instead of setup, there's another way we can do this. Dot setup. Let's see. Setup sequence. So now let's do this. Dot returns 0. Dot returns 1. So the first time count's called, we say, okay, it should be 0. Second time it's 1. And now let's see what happens. Not null. Something was null, but got a little further this time. So where did this one fail? It's so hard to see. Can I expand this box? I don't want to dock it. It's so hard to actually read. Let's dock it. That's all there is to it, actually. Okay, that's not a lot of help. It's failed at line 43, so the value we retrieved from find player, so that makes sense. So we didn't mock anything in find player. So we got past these stages, though, so okay, that's pretty good. So there's some more. So let's use the power of our mock here, and we'll keep fixing it later. So mocks give you the ability to see what happened here. So we didn't do any setup for heap or tree, but let's see what happens now. So if we do, let's do mock dictionary dot verify. So this says, okay, let's see what happened. So I'm going to say dictionary d dot count dot no verify no. I may have to go glance at this to make sure I know what I'm doing here. Let's see. Verify. Okay, yeah. That should have been it. Wait a minute. So here, comma. That's what I was going for. It was not the right preview. So we have a times here. So times, so if I say once here, it's going to fail because it should have got called twice. And we can confirm that here. We run it. There we go. Test failed. Why aren't you showing me what failed? There. This time it failed because expected invocation on the mock once, but was 2 times. So it's saying count got called twice. Doing that, you can follow through your flow. So let's do this times dot exactly 2. So exactly 2 calls. Now we should get that null exception again. Yep, there. So value is null at line 45. Yeah. Okay. So we verified that. So now we can do the same thing. Verify. d.insert times dot once. So it should be a once. And insert needs some information. So here we can pass in our player here, and this should work. Test player. So let's see if that works before I say 100% it should. I think it will. We should get our null again. Value is null. Okay, so that does work. What you can also do is if you don't, like say you don't care what player came through, you just wanted to insert a player, You could also do something like this. There is a it dot is any player. And there it says anytime there's a player, it should be fine. And you'll find that can be really useful a lot of times as well. For our purposes here, let's just confirm that works. For our purposes here, though, we have the test player, so we can just confirm that we get the one we expect. All right, so that will work. We can also just, for our case, we can just make it player, and that's fine as well. We've got some other things though. We didn't do any setup here, but I think we can use the heap. Verify. Insert. Test player once. And I think we can do the tree as well. I'm not sure if we might have to set these up. One of them you don't have to set it up in, and it'll figure it out. One of them does, but I can't remember which mocking framework I'm remembering. Yeah. So this one, it knows, even as long as it doesn't need, you don't need to use a value it returns. It thinks this is fine. I don't think insert returns anything, does it? Yeah, both of them are void anyway. So yeah. So now we are saying, okay, we call count twice. At this point, we've called insert once, insert heap once, and insert into the tree once. Then we do this find player. So find player, we also need to do the mocking here. So at this point, though, we could pretty effectively say, okay, the add player, it's done all the counts we expect. It's added the value, so we can say, okay, it has been added. And at that point, maybe we don't even need the find player test here. Maybe it needs to be separate. So at that point, what we've tested is that we can insert and all the values line up. So maybe that's actually all right. So now you can get philosophical about your testing. What are you testing? Where does it make sense? For us, I'm saying, okay, this has tested the good path here. So we have tested it. Now do we want to do more verification? So for us, we're saying we've added it everywhere, I guess, is what we really come to. We've inserted it into these. So we weren't testing that before. So maybe we're a little further along on testing. Maybe we're less far too, because now we're having to make fake operations. So there's some trade-off there. So what we would want to be able to do is say, okay, we've tested these pieces. Here we can combine them, and we can see that the combinations work. In doing so, we can say, okay, everything worked as we expected. So as such, I don't know that there's a lot of value in these tests specifically. May consider making find player its own test category, and maybe that's the next step actually. So maybe we'll hold off on that. So maybe we'll do a to do test find player. And that gives us a place. So all the testing we've done thus far has been unit testing. So the next step is integration testing, and that's where I'm thinking I want to go for actually combining things. So we may go ahead and just stick with unit testing at this point in time. And at that point, then we don't need these. I think this is sufficient for unit testing, actually. And actually, it's a lot of testing that when you're working on your system, you and your team can decide what makes sense for what you care about. Because I could easily make the argument that the original condition was perfectly fine as well. It's just we're going to have trouble testing some of this logic down here while this allows us to do, we can say, okay, we get 2 counts, we do all these inserts, we have inserted into the tree. So I would argue that this one's more complete. I would argue this one's more like what the user would actually see. So you can make an argument either one of these is right. So I think for next time we're going to keep doing this. We're going to get all these tests passing again, because right now, comment these out. Okay, there. If I comment those out, this test will now pass. And it did. So now we would need to go pass through these changes elsewhere. So that'll be the next lesson. We'll get this back to green, and then we'll start looking at these fine players and finishing up this testing here. So I think that'll be a good direction to continue on, and we can keep messing around with tests a little more. So for the sake of this test here before we finish, so since we set up this and then we actually verify values here, these are mocks, and we use that name. The other ones, I think the next most common one I've used is called a stub. And a stub, basically, it just always returns a value, so you never care about what you set. And in fact, we don't need this line. So if we never verified count on the other end here, so if we didn't actually do this count verification, this would be a stub, is how I've heard the terminology. So it's like, we're giving you this value, what happens? Since we do the actual verification here, though, it becomes a mock. And that's how I've heard the difference between them. So the third one is a fake. I've used them a little bit here and there, and from how I've always heard the terminology, a fake's just a fake implementation. So you might have a more complicated implementation of something somewhere, but then you might have a test. Player's not a good example of. Maybe you have a test tree, and the insert always adds something, and the remove always removes it. And it has basic functionality, but maybe it doesn't act like a tree. Maybe it acts more like a list. So you've got some simplified functionality, but you've got the more complicated one. And what you're doing is you're isolating whatever you're testing. So your unit, maybe triad player here doesn't care about the behavior of the heap or behavior of the tree. It just cares that something was inserted. So you're adding a fake tree, basically. And we could use that route as well. But I believe we're going to call it there. We're going to say that's good enough for now, and next time we're going to work on getting your tests passing. So thanks for watching, and have a wonderful rest of your day.